Welcome back to Module 2, Physics. In this video, we continue optics, covering curved mirrors, lenses, and how fiber optic cables use total internal reflection. A concave mirror curves inward, like the inside of a bowl. Parallel rays striking it are all reflected through a single point, the focal point F, located at half the radius of curvature. This is why concave mirrors are used to focus light or to magnify a close-up image. A convex mirror curves outward, like the outside of a ball. Parallel rays striking it spread apart after reflecting, so they never actually meet. Instead, they appear to come from a virtual focal point behind the mirror. This spreads out a wider view into a smaller image, which is why convex mirrors are used for wing mirrors and wide-angle safety mirrors. A convex lens is thicker in the middle than at its edges. Light passing through bends inward, converging to a real focal point on the far side. The lens equation, 1 over f equals 1 over u plus 1 over v, links the focal length to the object and image distances. A concave lens is thinner in the middle than at its edges, the opposite shape to a convex lens. Light passing through it bends outward, spreading apart. The rays never converge, but they appear to come from a virtual focal point on the same side as the incoming light, always producing a virtual image. A fiber optic cable has a core of glass with a high refractive index, surrounded by a cladding layer with a lower refractive index. Light entering the core at an angle beyond the critical angle undergoes total internal reflection every time it meets the boundary, bouncing back and forth along the whole length of the cable without ever escaping. Here is one for you to try. A concave mirror has a radius of curvature of 40 centimeters. Calculate its focal length. Pause the video now. Read the question and select your answer. The correct answer is B. Convex mirrors always give virtual images. Read the question and select your answer. The correct answer is B. Convex lenses converge light. Read the question and select your answer. The correct answer is CTIR keeps light bouncing inside the core. That completes video 19. Next time we finish Module 2 with wave motion and sound. See you there.